Assalamu alaikum. How are you? In this video, we'll explain Physics Chapter 5, Section 3, Conservation of Energy. Objectives of our lesson: to explain the meaning of conserved quantities and what's meant by conservation, define the law of conservation of energy, identify the conservation of mechanical energy, and solve some problems using conservation of mechanical energy. Let's start. What's a conserved quantity? Conserved means unchanged, remains constant. So when we say that something is conserved, we mean that it remains constant, doesn't change. For example, mass, law of conservation of mass. Mass doesn't change, remains the same. Energy, law of conservation of energy. Energy is a conserved quantity. What's meant by conservation? So, the law of conservation of energy states that energy neither be created nor destroyed, but can change from one form to another. Energy cannot be created from nothing, or cannot destroyed or vanish, but can change to other forms. Like in the electric bulb, electric energy changes into light energy and some heat energy, and so on. The plants take sun energy and converts it into chemical energy. So energy neither be created nor destroyed, but can change from one form to another. Mechanical energy. What's mechanical energy? We discussed it before: kinetic energy and potential energy. So the sum of kinetic energy and potential energy is called mechanical energy. So the sum of kinetic energy and all forms of potential energy, gravitational potential energy, elastic potential energy, all of these, the sum of kinetic and the potential is called mechanical energy. So mechanical energy equals kinetic energy plus potential energy. Mechanical energy is also a conserved quantity under a certain condition. What's the condition? Neglecting air resistance or neglecting friction. If there is no friction, no air resistance, the mechanical energy is often conserved. So, means what? The initial mechanical energy equals the final mechanical energy. Conserved quantity, mechanical energy is conserved, means the initial mechanical energy equals the final mechanical energy. Initial mechanical energy equals final mechanical energy under the condition that in the absence of friction. Because friction, if friction exists, some of the mechanical energy is converted into other forms of energy like heat. Let's discuss this example to explain the conservation of mechanical energy. This object is falling down from a certain height. For example, now it has potential energy 120 joules at the maximum height. And it starts motion from rest, so its kinetic energy equals 0. When it falls down, its height decreases and also its potential energy decreases, so the potential energy becomes 60. And the kinetic energy increases because its speed increases. The kinetic energy becomes 60. And it falls down again to reach the ground. The potential energy equals 0 because the height equals 0. And the kinetic energy is maximum equals 120 joule just before hitting the ground. So, what do you observe now? What's the mechanical energy at the highest height? Kinetic plus potential, 0 plus 120 equals 120. Here in the middle point, 60 plus 60 equals 120, the same mechanical energy. Here on the ground, before hitting the ground, the kinetic energy equals 120 and the potential energy equals 0. So the mechanical energy equals 120. So the mechanical energy now is the same, neglecting any friction force, any air resistance. So the mechanical energy is conserved, is the same, 120, 120, 120. Clear? Okay. Let's discuss an example. Starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What's her speed at the bottom of the slide? Assume she has a mass of 25 kilograms. She slides down. From a height of 3 meters and its mass is 25 kilograms. What's given here? The height or the initial height equals 3 meters and the mass equal 25 kilograms. The initial velocity equals 0, starts from rest, and the final height equals 0 at the ground. So unknown is the final velocity. You are asked to find the final velocity after sliding down. You should remember that kinetic energy equals 1/2 mv squared. Kinetic energy equals 1/2 mv squared. And potential energy equals mgh. Okay? The initial gravitational potential energy at the top of the slide is potential energy equals mgh initial or mgh. The final gravitational potential energy is 0. Be final equals 0 because the height equals 0. The initial kinetic energy at the top is 0, starts from rest. Initial kinetic energy equals 0. And the final kinetic energy is 1/2 mvf squared. Vf, the final velocity, which is unknown. Substitute. Potential energy initial equals mass times g times h, mgh. Mass 25 times 9.81 times 3 meters equals 736 joules. So this is the initial potential energy. And the final potential energy equals 1/2 mv squared. 1/2, the rule, 1/2 mass times velocity squared. Velocity here is unknown. So use the conservation of mechanical energy law to find the final velocity. The conservation of mechanical energy, initial mechanical energy equals final mechanical energy. What's the initial mechanical energy here? The initial mechanical energy PEI plus KEI. Potential energy initial plus kinetic energy initial equals potential energy final and kinetic energy final. Okay, so this is a conservation of mechanical energy. Initial mechanical energy equals final mechanical energy. The initial potential energy we calculated it to be 736 joules. Initial kinetic energy equals 0 because it starts from rest, equals potential energy final equals 0. Why? Because it reaches the ground. The height equals 0, so the potential energy equals 0. Kinetic energy equals 1/2 m times v squared. V squared here is unknown. The left hand side will be 736 joules and the right hand side will be half times 25 equal 12.5 Vf squared. So dividing by 20.5 to 12.5 both sides, Vf squared will be found, and then finding the square root of Vf squared, it will be Vf equals 7.67 meter per second. And this is the final velocity down the slide. Mechanical energy, as we mentioned, is not conserved in the presence of friction. Here, if there is friction force, the mechanical energy is not conserved. As a sanding block slides on a piece of wood, energy in the form of heat is dissipated into the block and the surface. The mechanical energy here is changed into heat energy, and the block and the surface become warm. So here mechanical energy is not conserved because of friction. Okay guys.